Okay, so I think we can start. So, hello everyone. Uh, Welcome to a new session of our workshop series of AI2E, AI Every Time, Everywhere. So today is a bit special as we host Beril Sirmacek. I don't know if I'm telling it right.
You pronounce perfectly. Thank you.
Okay, perfect. So thank you for joining us for this session. And Beril is actually an assistant professor in a Sweden university and have been using deep learning in many of her research. She was, I think, the Dean of School of AI Netherlands.
Yeah.
Yes. So welcome and thank you for this talk. And you can start whenever you want.
Thank you very much for invitation and this introduction. Hi everyone. I wish I could see all of you. At the moment I cannot, but I'm so much honored to meet you online. Thank you very much for being there. And well, thank you for still continuing School of AI even in this difficult situation. I believe it's very useful. And I'm Beril. I used to be the School of AI founder from the Netherlands. I'm originally from Netherlands, and since beginning of 2020, I started to work in Sweden since I hold a faculty position here at the AI lab. And I'm happy to still work with, deeply engaged with AI and working within several different projects. And in all, I'm applying AI to computer vision field, which means that, well, making the camera see and understand the information like human does, hopefully. But today I will not talk to you about computer vision. I will talk to you about processing another type of data, not vision data, but sound data. Let me share my presentation slides with you, then we go through them. I hope I can find the... I think I have to share all my window. No, that didn't work. And your entire screen. Okay, let's try like this. Okay, if you are seeing my screen, I can continue. And we will look at how we can use AI to process sound, not image. And there's no camera, but assume that there's a microphone in the environment, or in smartphone, all of them have microphone, how to process data and understand. This is something that Alexa, for instance, or Google Assistant all the time does. All the time they wait to hear Alexa, or saying maybe Siri, if it's Siri, or if it's Google Assistant, waiting for hearing hello Google. So how they are processing data with AI? If I was using images, my task would be simpler maybe, because my input with images would be numbers. A digital image, like for instance, I'm looking at an image of letter T at the left-hand side. If I look at each pixel is a number. So it looks like 1 and zeros, like the matrix at right-hand side. Then my task would be easier, because then I could put these numbers into a neural network and I could train it until I reach to a small loss number, and all the weights are determined after training. But how to do it with sound? Assume that you've got sound, and that's only an analog input, or we somehow either convert the sound into letters or assume that we've got letters given. How to give this to neural network? There's no straightforward way. We have to digitalize this. And how? In order to provide it to neural network. One thing we can do is to give a token to each letter. We could, for instance, assume the word not, and for each letter, we can give a unique token. Let's say N gets 100, O gets 0, 12, and T gets 200. Then each word is converted to digits. Okay, that sounds good. We've got a vector now for not. But what happens if you see another word which looks like this? Ton. And ton has then uh, given the similar or given the same tokens, it would have 200, 0, 12, and 100. And their vectors are look so similar, even though their meaning have no relation. So we've got no idea about the meaning of the words, even though we digitalize them. We cannot do understanding in this way. So there are two problems. We said one is if we put these numbers into vector space, which we call embeddings, they look very similar, even though they are carrying very different meanings. It's not possible to identify different meaning words. And the second, in this way, we cannot go through understanding semantics if we are talking about something positive or negative. So no way to distinguish words and the meanings. So what we can do, instead of giving a token to each letter, we can give a token to each word. Then assume these three sentences. I love potatoes. I love tomatoes. You love potatoes. And then giving a token to each word works like this using TensorFlow. It's quite simple. You import TensorFlow, STF, as you always do. And second line I'm going through, you import Keras to make your later neural network design simpler. And what you need is to also import from Keras pre-processing text, you have to get the tokenizer. That's what we really need. So tokenizer does assigning tokens by itself. You don't need to write a lookup table like something. You don't have to assign a unique code to each word. It does it for you. So what you need to do is to write your sentences for training. For instance, I love potatoes, I love tomatoes, you love potatoes. And when you call the tokenizer, first you initialize it with a number of words that you are going to use. Let's say 100. There are not 100 words in my data set, but it's good to be safe and give something a little bit higher than you expect to have in your training set. And then when you say fit it on my sentences and you get the tokens and print them out, let's see what's printed. Love has token 1, I has token 2, potatoes has token 3, tomatoes has token 4, you have has a token 5. So each word here gets a unique token. So it's done already. It's that simple. And here, one main advantage of using Tokenizer of TensorFlow is that it does everything for you, and it also cleans the text that you've given for training. For instance, if there are some commas or exclamation mark or strange emojis, maybe you get these sentences from Twitter API instead of writing them yourself, and there are some emojis around. So this tokenizer function also cleans all of them and gives you tokens assigned to words only, to clean words. And what happens if we write tokens of my each sentence? I love potatoes, I love tomatoes. Look how similar. I love 213 and I love 214. So it's already easy here to understand if these two sentences are similar. So if I'm talking about something positive that I find, so it's also possible to see that here 5, you love potatoes, suddenly changed because another person is mentioned. So it's now possible to look at the meanings and the similarity between sentences easier in this way. So what applications you can do in this situation when you've got tokens for your words and your sentences are digitalized? And you can, for instance, automatically search articles and look if the article is positive or negative. You can either make it a recommendation system. For instance, if the article is the type of the article that you normally read, maybe it's a recommendation system, recommends the article to you. Or you can make maybe blocking app. Maybe if the article is so negative, maybe you can make an app which blocks those articles from you. You can automatically read news headlines and maybe pick up group the interesting ones together. You can identify a person. How does it work? If the person, for instance, has a speech pattern and the person always talks about the same way, probably you will see a repetitive pattern of the words within the sentences that he or she is using. So maybe it's even possible to identify if this person has written this text or if this person has spoken these words. It's possible to classify different topic articles and maybe make a nice web page which is customized to user, always giving you like Pinterest, collecting the articles which I would like. And you can also make a prediction system like the Google Gmail does. When you're typing something, I want to go, and then it completes. How does it do that? How is it trained? It's trained by using lots of sentences, and also it's learning all the time the sentences that you make most of the time. But the prediction system requires a different kind of AI. It's not classification, it's not clustering. So what is it then? It's the prediction system I will mention. Here's one more application that you can do. Maybe it's quite useful. At home, instead of putting cameras, you can put a microphone to hear sounds. And maybe you can classify different sounds if the person is fell down, or something in the kitchen is boiling so hard, or something broke down. Those kind of sounds maybe you can pre-train, and your neural network classifies later when it hears a new sound to identify if there's something emergent going on at home and what's going on exactly. So let's go back to prediction part that we mentioned. How do we make something like Gmail's autocomplete? How to predict the next word? So of course we can get a crystal ball and make a prediction what the next word could be, but we are not doing in AI. We are using a neural network which is sequential. So in the past, we used to use recurrent neural network, which is, for instance, looks like the left-hand side, and this is trained by a time series of input. And time series, you assume that there's always new sentence is coming, and it's trained and again and again. Here, HT is the output, but when there's a new data, it's always updating itself. It's learning something new, how to predict the next word. And When you look at the time series as zero input, one input, two input, like if you open this left hand side, the neural network looks like RNN looks uh, like this. However, in this training process, there is a difficulty. When you're training with a huge data set with a lot of sentences, and for instance, you have trained with some sentences in very early stage at time 0 and 1, and you gave more example sentences to train neural network, it's trying to learn what comes after what. And here, when you trained it more and more, the neural network is updated so many times when you gave so many training examples. And in this stage, it already adapted to the very latest training examples, and it forgot how to respond to these training examples, to these sentences. So the neural network is always being updated, but if you update it with so big data, it forgot already very past information. And for instance, in this case, it works like this. In the beginning of the text, which is training data, let's say I said something like this. I go to France every summer. This is my first sentence. Then the neural network is trying to learn what's coming after what. My second sentence in the training dataset is this. I stay in France very long. Okay, that's the second sentence. It's learned what comes after what, and it's trying to learn the sentence decomposition. And then I explain something. When I go there, I get a dog, I eat ice cream, I swim, and I climb to mountain, and it continues learning each sentence. And then after a while, I say, I speak. And then I expect, for instance, the neural network, if it's trained already, to predict the next coming word in the test period. And if it's already trained with my story in France, in the test of given the word I speak, I would expect it to say, I speak French very well, because it should have learned already from my story of staying in France so long. But the neural network learned in the process, I stay in France and I stay there very long. That was coming in the first two sentences, and I never mentioned France anymore. I talked about dog, ice cream, sea and mountain and all the other things. And it forgot. The neural network was adapted to my first sentences here, but then it's not adapted to these very first sentences anymore. It's updated a lot. And in the prediction phase, if I want to use the neural network for prediction, it cannot predict that I can speak French very well. I mentioned France, but it forgot. So in order to cope with this issue of RNN, we use LSTM. And LSTM looks like RNN, but within inside, there's a forget gate and there's a memory gate. And through the training with a training process with a long text, it's trying to learn what kind of word series to forget, what kind of word series should I remember, should I keep in my memory. So this LSTM structure is becoming more strong to learn in a sequential training phase, because when my network is being getting adapted to new training data, it's not forgetting important elements that I mentioned, like I stay in France, I go to France every summer, like I mentioned so much ago, but still it keeps in the memory. It learns how to keep in the memory important things and to respond later in the prediction step. When I say I speak French, it remembers in the memory that how to complete the sentence. So in order to train the LSTM, we need a lot of data set, a lot of sentences, and according to TensorFlow material, long sentences are not suggested to make prevent overcomplications. And you also need to give the sentences at the same length, because the input of the neural network should be always the same size. Then if your sentence is shorter, you have to apply padding, maybe put some zeros at the end. And LSTM writing in TensorFlow is only a few lines. Of course, this is very basic LSTM you see at the moment. You can make it more sophisticated by adding maybe more dense layers, but maybe you can try it as it is. You just create a model, a neural network model with a sequential way, and you say how many words as input you want and how many LSTM neurons you want, and you add a dense layer. Activation function is chosen. You choose your learning rate, and you say compile my neural network model, and it's there, fit my training data set, and you train the LSTM. It's only 7 lines that you see here. By the way, you can change the activation function, of course. We don't know exactly what should work best, and you can also change the learning rate. We also don't know what should be the best learning rate. Of course, if it becomes small, then the training will take a lot of time. And if it becomes too big, training takes shorter time, but you might skip some minimums and maybe not optimized very well at the end. And finding data set, I would suggest you to look at this Kaggle competition. If you go to the link Kaggle, and there's a news headlines data set for scars detection. If you search for it, you will find a lot of news articles where they classified, they put labels positive and negative. So you can train your LSTM with sentences from news. And well, if you're interested, you can also look at my GitHub. I've been collecting Swedish Twitter engagement, the top Twitter posts in Sweden about COVID-19 from the beginning of March, and to see how the sentiments are going positive and negative. So you might also use that, or you can make your own Twitter data analysis. It's quite simple by using Twitter API. So if you are familiar with Google Cloud products, you can go to embedding projector, and you can upload your training set, for instance, to see the distribution of your data. You can see if your sentences are converted to vectors after tokens are assigned, of course. You can visualize how your sentiments are distributed in the space. Of course, your sentences will have many dimensions, which is equal to the number of words, but here it's making the visualization simpler by using PCA transformation, so it can plot in 3D. And you can also here look and see the positive and negative distribution. And you can also click on each token in the distribution to see if they are really presented very nice in the 3D space. For instance, when I click on happy, I also see lucky, beautiful, funny like things around it. So positive things are close to it and negative words are far away from happy. So it also shows that my tokens are assigned well and my distribution is quite equal or not. So it also helps with visualization. And last, if you want to hear more from me, I would be happy if you go to my website. You can go to newsletter, very tiny little. I don't know why I made it invisible almost. Go to my newsletter and subscribe. I send monthly newsletter, and it includes a lot of source code, data sets, and the lectures that we've recorded. You can also, in this page, click on the YouTube and subscribe to YouTube page. I'm sharing all my lectures on YouTube, and you can also follow me on Twitter with my first name and surname. So that concludes my presentation. Thank you very much for hearing, and if you have questions, I will try to answer. I was looking at the chat if there are questions, but I didn't see any. Would you like to ask any questions, or you can also type in the chat if you don't want to speak? Okay, I leave the floor to you then. Thank you very much for inviting me.
Okay. Thank you very much for accepting and for this talk. We really enjoyed it. So I don't know if they have any question.
Thank you for writing your thank you comments, and I hope to hear from you later again online. And have a great day.
Thank you. Have a great day too. Thank
Bye.
you. Bye.